Looking at this problem, the instructions give me the opportunity to choose any method that I want to solve this quadratic equation. When I first look at this problem, I see that I have this binomial squared. So I'm thinking that I'm going to use the square root method here. I'm thinking I can get everything squared on one side equal to a constant on the other so that I can take the square root of both sides. That's the method that I would choose for this specific problem. So to do that, I need to move my constant first. Let's subtract 6 from both sides. If you subtract 6 from both sides, the 6's cancel. You end up with 4, open parentheses, x minus 2 squared equals to 36. 4 is being multiplied times this binomial squared. So to undo the multiplication, let's divide both sides by 4. The 4's cancel. We end up with x minus 2 squared equals to 9. Next, to undo something squared, we'll take the square root of both sides. The square root of something squared gives me x minus 2 equals 2 plus or minus the square root of 9. Next, let's add 2 to both sides, still solving for x. Still trying to get x on one side by itself. So we have 2 plus or minus the square root of 9. The square root of 9 we can break on down to the square root of 9 gives you 3. So your final answer breaks apart as 2 plus 3 and 2 minus 3. Anytime that you can continue on, do so. 2 plus 3 gives you 5. That's one answer. And 2 minus 3 gives you negative 1. That's your other answer. So you have two answers to this problem, positive 5, negative 1. But notice the beginning steps that I took. The first thing I had to do was subtract 6 from both sides. You cannot divide both sides by 4 to start with. You have to subtract 6, move the constant, then divide both sides by 4. Then take the square root of both sides. Then if you can continue on, the square root of 9 comes out as 3. So you still had 2 plus 3 and 2 minus 3. So your final answers are positive 5 and negative 1.